All right, let's see if I can get through balancing before my battery dies. So, balancing reactions. This is the second to last step in writing the perfect chemical equation. But why balance? Why is this important? We have to satisfy LCOM, the law of conservation of mass, or matter, whichever you prefer. LCOM says that matter cannot be created or destroyed. So that means that my starting mass must equal my ending mass, unless we're doing nuclear chemistry. Then you might transfer it into energy, the mass, but not here. So starting mass equal ending mass, which means my starting number of atoms and my starting types of atoms has to equal the same type and number of atoms on the product side. So this is going to represent what's actually happening in my beaker. Just like it takes 2 pieces of bread to make 1 sandwich, sometimes it takes 2 of one molecule to produce 1 of another. So we have to make sure to indicate that ratio in our equation. Never, ever, never, 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 ever, 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 never use subscripts to balance an equation. Don't do it. You might be tempted, but don't do it. Subscripts are only for balancing charges, so don't do it. Subscripts, not for balancing for LCOM. Instead, we have to use coefficients in front of our compound to balance the number of atoms. Notice, in front, just like I can't stick a 2x4 through your shoulder blades. That would make not a live person, but a dead thing. I can't stick a coefficient in the middle of a compound because then I don't have a compound anymore. I broke it. I have a dead thing. So, coefficients go in front. For example, here I have 1 magnesium. I'm going to use my drawing method here. I have 1 magnesium, 2 oxygens, and then over here on the product side, I have 1 magnesium and 1 oxygen. Notice, 2 pinks on the left, 1 pink on the right. Not okay. I can't have atoms popping in and out of existence. So, in order to fix that, I need another oxygen over here on the left-hand side. But, remember the 2x4. I can't break this into its pieces. I have to have another of that whole molecule. So now, 2 pinks, 2 pinks. Huzzah! But nope, that was a thumbs up there. 2 magnesiums, whoop, only have 1 magnesium. Gotta put another one. Now, number of atoms on the left matches number of atoms on the right. Type of atoms on the left matches type of atoms on the right. All that's left to do is put in our coefficients. I drew 2 magnesiums, so it gets a coefficient of a 2. 1 oxygen, it's already there, and 2 of my magnesium oxide. And this guy right here is my balanced chemical equation. So let's try another. If you know the tally method, I'm getting there. But first, let's draw this one too. If you're a visual learner, this is a great way to pick up on these. So let's see, I have 1 calcium with 2 chlorines. Over here, I have, let's see if you can see my yellow, 3 NAs. Alright, you can, huzzah. With 1 phosphate. On the other side, let me get my colors right. I have 1 Na with 1 Cl. Let's see, how about my calciums? What color did I draw that in? Orange. 3 calciums and 2 phosphates. Oh good, we're still rolling. Okay, so right off the bat, notice 1 calcium, 3 calciums. Ooh, not okay. So, remember the 2x4 can't break this and just draw more calciums. I have to draw the calciums with the chloride. So let's see, I need 2 more of this molecule. There we go. Each of those calciums comes with 2 chlorines. There they are. Alright, 3 oranges. 3 oranges. Check. But that threw my chlorines way out of kilter. 6 chlorines here, but one lonely chlorine here. So I got lots more of these NaCl's to draw. Let's see if they'll all fit. I'm going to draw my last one up here. Each of those NAs comes with a Cl. Alright, so now 6 chlorines on the left, 6 chlorines on the right. Yes, I know I pointed them the wrong direction, sorry. But now my sodiums are off kilter. 6 sodiums here, 3 sodiums here. So let's see, I get 3 sodiums with 1 phosphate. Now let's check. 3 calciums, 3 calciums, 2, 4, 6 chlorines, 2, 4, 6 chlorines, 3, 6 sodiums, 1, 2, 3, 4, 5, 6 sodiums, 2 phosphates, huzzah! Now let's add our coefficients. Here's 1 calcium chloride, 2 calcium chloride, 3 calcium chloride, 1 sodium phosphate, 2 sodium phosphate, 1, 2, 3, 4, 5, 6 sodium chloride, and but 1 lonely calcium phosphate. Huzzah! Alright. Let's try another one. Ooh, now we gotta translate. Let's see. Silver acetate +1 -1. Yay! Reacts with manganese with a 3+ charge, oxide with a 2-. There we go. What type of reaction is this? I got 2 compounds, totally different. Makes this a double replacement reaction. Double replacement reaction means we're going to do-si-do. All of my ions are going to switch. So my silver now goes with my oxide. Whoa, that doesn't equal 0. My manganese is now going to go with my acetate. Whoa, that doesn't equal 0. Okay, now let's balance. Let me show you the tally method this time. The tally method is just going to look at each of the ions involved, and we're going to tally up how many of the ions are on each side. Notice I kept my acetate together. Since it's together over here, it's together over there, I don't have to break it apart. So I'm going to make my life simple and keep it just as is. Let's get a different color here to make this more visible. Now we're going to count. 1 silver on the left, 2 silvers on the right, 1 acetate on the left, 3 acetates on the right, 2 manganese on the left, 1 manganese on the right, 3 oxygens on the left, 1 oxygen on the right. Now, in case you hadn't noticed, left side most definitely does not equal right side. So we got some work to do. So, the beginning, always a good place to start. Let's start there. Need 2 silvers over here, so let's put a 2 in front of my silver. That gives me 2 silvers and 2 acetates. Whoa, my acetates don't match. I got 3 over here, now I have 2 over here. That doesn't work. If I put a 3 here, then my silvers wouldn't match. Let's come back to that one. Let's check out our manganese instead. 2 on the left, 2 on the right. If I put a 2 in front of my manganese, that gives me 2 manganeses, and the 2 is going to distribute to the manganese and to the acetate. My acetates are coming in sets of 3. So that means now 2 times 3, I have 6 acetates. Hey, I can get to 6 acetates. So let's change this subscript in front of the silver here. Let's put a 6 instead. That gives me 6 silvers, distributes to both the silver and to the acetate. 6 acetates. Whoop, let's go fix my silver over here. It's coming in pairs. So 3 times 2 gives me the 6 I was looking for. Not only that, but it gives me 3 oxygens. So there we are, our balanced chemical equation. Let's try one more this way before I run out of time. Mercury oxalate. Let's see, mercury Hg plus the 1 there. Oxalate C2O4, and he has a -2 charge. Whoop, now it's balanced. Reacts with tin with a 4 charge. Sulfate with his -2. Alright, now it equals 0. What type of reaction is this? Go back, look at your notes. I have 2 compounds. So this is going to be one of our double replacements. Do-si-do. So the tin with his 4+ charge is going to go with the oxalate, 2-. Whoa. Now it equals 0. Plus mercury with his +1 charge goes with the sulfate. I'm going to need 2 of the mercuries to take care of that sulfate. Alright, now let's balance. I've got an Hg, an acetate, a tin, and a sulfate. Alright, let's tally. 2 mercuries, 1 oxalate, 1 oxalate, 1 tin, 1 tin, 2 sulfates, 1 sulfate. Alright, let's see what's off. My sulfate is the only one that's off. Did I do that right? I did, okay. Whoops. There's what I messed up. I knew something looked off. Okay. Now, quickly, let's see what we need to fix. My oxalate and my sulfate are off. So let's see. Here is my oxalate. If I put a 2 in front of that, 2 times 2 is 4 mercuries and the 2 oxalates that I wanted. My tins are good. Sulfate. I need 2 sulfates over here on the right. So let's put 2 there. That gives me 2 sulfates, but also 2 times 2 is 4. Huzzah! That one was nice and simple. All balanced. So, always double check. Now you have 2 methods. You can either draw out all of the ions like this. Nothing wrong with that. Takes a little more time, but the visual method is always nice. Or you can use the tally. Next video, we'll cover solubilities. And so we're still going to have to balance our equations, but we're going to tack in the last piece called solubility. See you next time.